Greetings. This is our last chapter. Again, if you've done great on all your other tests, you could probably just skip this test. If you haven't done great on your test and you want to drop a low score, this is a pretty easy test. So we're going to talk about oxidation numbers. So the oxidation number of something is the number that an element would get if its most electronegative atom took all of its the electrons. So if we kind of talked about when in an ionic compound what charge something would get, and so remember this row kind of wants to steal one electron, so this row kind of gets -1. They steal one electron, that gets a -1 charge. This row over here wants to give away an electron, so they would be +1 charge because they gave away an electron. So just keep in mind that oxidation numbers aren't actually real. It's kind of a theoretical thing to kind of give us an idea of what happens to the electrons, but they never really achieve that charge. So it's kind of a theoretical thing. And there's rules to assign oxidation numbers to things. So the first thing you need to remember is that the sum of all the oxidation numbers in a molecule must equal the charge on that molecule. So if here we have iron, there's no charge on iron, it's Fe, so there's no charge on it, it's not positive, it's not negative. So iron in this case has to be a 0 because there's only one element and the charge on the overall thing has to be 0. So it's 0. But now if this iron has a charge of +3, iron is going to be +3. So the oxidation number of that one would be +3. So now I'm going to do on page 527, this is example 16.1. Suppose you know that the oxidation number of Mg and MgBr2 is +2. Well, if there's no overall charge on it, it's got to be a 0 overall charge. So, oops, this is Br2. So then to cancel out that +2 charge, Br has to be -1 because there's 2 of them. So you would have a +2 and then a -1 and a -1 to give you an overall charge of 0. So the charge on Mg must be +2 and the charge on Br must be -1. Does that make sense? So you're just assigning a charge for everything. So here we have HBr03. So the hard thing here is just to remember that to count all of your atoms. So they're telling you that H is +1 and O is -2 and it's got no overall charge. So that means they didn't tell us what Br is. To calculate that, we would do +1, there's 3 oxygens, so that'd be -2, -2, -2. But we want to get an overall charge of 0. So if we have -2, 4, 6, +1 is -5, this has to be a +5 to give us an overall charge of 0. So you're just assigning a charge to these. But again, it's theoretical, it doesn't really happen, but we want to be able to see where the electrons are going.